Let us start exercise 1.3. Very important question. To prove that root 5 is an irrational number, we use the contradiction steps. Please note these steps carefully. Let suppose root 5 is a rational number. Then the rational number can be written as in the form of p upon q. So root 5 is equal to p upon q. Equation number 1, where q is not equal to 0 and p and q are co-prime. Co-prime means which have no common factor other than 1. Only 1 is the common factor of the two co-prime numbers. So p and q have only one common factor. So from equation 1 we get root 5 into q, root 5q is equal to p, or we can write it p is equal to root 5q. Next step, squaring both sides, then we get p square is equal to 5, square of root 5 is 5, q square plus 0 you can write equation number 2. By Euclid division lemma, a equal to bq plus r, we get r is 0, so we can say that this b divide a completely into q times, so we can say this 5 also divide p square completely. So q square is divisible by 5, so p is also divisible by 5. And let suppose this p, if this p is divisible by 5, then we can write in another terms p equal to 5m for any integer m. Then again squaring both sides, p square equal to 25 m square. Then put the value of this p square from equation 2, that is 5q square. Then 5q square is equal to 25 m square. When we cut this 5 to 25, that will be 5. Q square equal to 5m square. Again by Euclid division lemma, a equal to bq plus r, we get that q square is divisible by 5. So q is also divisible by 5. Since p and q are divisible by 5 here, but p and q are co-prime, this happened due to our wrong assumption. So our assumption that root 5 is a rational number is wrong. Hence root 5 is a irrational number. Same next question. To prove 1 upon root 5 is an irrational number, इस type की question कैसे solve करेंगे? There are same step just like a root 5 is an irrational number. Check. Let us start. Let 1 upon root 2 is a rational number. Same step. So we can write it in the form of p upon q. So 1 upon root 2 is equal to p upon q, where there are same condition, q is not equal to 0, p and q are co-prime. When we cross multiply, then we get q is equal to root 2p. Then same again squaring both side, then we get q square equal to 2p square plus 0. By Euclid division lemma, a equal to bq plus r, again we get this q square is completely divisible by 2. So we can say q square is divisible by completely divisible by 2, so q is also divisible by 2. Then let q is equal to 2m for any integer m. Squaring both side, q square equal to 4m square. Then put the value of q square from equation 2, then we get 2p square equal to 4m square. And cancel out this 4 by 2, then we get p square equal to 2m square plus 0 you can write. Again by Euclid division lemma, a equal to bq plus r, again we see that p square is completely divisible by 2, so p is also divisible by 2. P and q both are divisible by 2 here, but we know p and q are co-prime according to condition of rational number. So we can say our wrong assumption that 1 upon root 2 is a rational number is wrong. So hence 1 upon root 2 is an irrational number. सेम स्टेप्स हैं, प्रैक्टिस कीजिए, चाहे वहाँ पर 1 अपन रूट 5 आए, 1 अपन रूट 2 आए, 1 अपन रूट 7 आए, या रूट 5 रूट 3 रूट 5 रूट 6 रूट 7 कुछ भी आए, उसके सेम स्टेप्स हैं ये दोनों क्वेश्चन के, आप इसको रीड कर लीजिए.